So, knowledge. Knowledge is not merely about the accumulation of facts, but rather the art of uncovering the right information at the right time. In today's fast paced world, where information is abundant yet often overwhelming, the ability to navigate through the vast sea of data effectively is an invaluable skill. Whether you are a student embarking on a research project, a professional seeking to stay ahead in your field, or an enthusiast eager to delve deeper into a topic of interest. Mastering the art of unlocking library data and transforming raw data into insights through visualization is absolutely essential. Throughout this webinar, we will explore practical strategies, cutting-edge tools, and proven techniques to manage and present your most valuable library statistics and data for making the right decisions and accessing library performance through visualization. So starting with today's event, I would like to call upon Mr. Giridhar Kunkur, the librarian, LNMIIT Jaipur. Previously, he served as a librarian at BITS Pilani, which is an institute of eminence and is known for effectively transforming the BITS Pilani library. Under the leadership, the library has received Wiley's Digitally Transformed Academic Library 2019 award under non-government category. On 30th January 2021, the BITS Pilani Library won the prestigious Informatics Innovation Award 2021. Prior to this, he was heading the Learning Resource Center at Wellinkar Institute of Management, Development and Research, Mumbai, where he was instrumental in revamping and redesigning the library to go with the modern trends and awarded the Customer Success Award for Best Practice through Technology Innovation by EBSCO in appreciation of demonstrated efforts to share successful initiatives with the community. For 24 years, Mr. Kunkur worked for the British Council Libraries in India in various capacities. He successfully served as Head, Library and Information Services, West India, British Council, Mumbai. Mr. Kunkur is a recipient of the prestigious many awards in the field of library and information science. Over to you, sir.
Thank you very much, Perini, for that introduction. Good afternoon, everyone. Professor Subrat Das, Chairman, Library Advisory Committee, LNMIIT Jaipur. Dr. Vinit Kumar, Assistant Professor, Department of Library and Information Science, Babasaheb Bhimrao Ambedkar University, Lucknow. Mr. Shubham Giri, Assistant Librarian, LNMIIT Central Library. All distinguished faculty members, esteemed librarians, research scholars, library professionals, students, ladies and gentlemen. On behalf of LNMIIT Central Library, Jaipur, I am delighted to welcome you all to this national webinar on unlocking library data, transforming raw data into insights through visualizations. It is indeed heartening to see such an overwhelming and enthusiastic participation from all over India, and we are thankful to each one of you for joining us today. Friends, you all will agree that in our libraries, wherever we are working, we generate a lot of statistics related to our activities, resources, services, collections, acquisitions, transactions, footfalls, usage statistics of all our print and digital resources, budget utilization, infrastructure, data entries, so on and so forth. These statistics or data are actually an evidence-based reflection on our library performance. It also showcases the performance of the library staff members, and at the same time, it allows us to make informed decisions to improve, correct, modify, or even discontinue some of our services or resources that are not being used so well, and introduce new services and resources to go with the current trends. The question here is how we manage this data or statistics in our libraries and whether we are using it for informed decision making and improving our services. It is not enough to simply generate these statistics, but also we should be able to ensure that they are organized, utilized effectively. Perhaps many libraries are facing challenges in managing their data efficiently. If statistics are scattered across various folders on different computers, you can imagine there is a big risk of losing valuable insights or not utilizing them to their full potential. The very purpose of this national webinar is to look at the prospects of addressing these issues, and we need to implement robust data management systems that centralize and streamline the storage and tracking of statistics, utilizing specialized software which are designed for library data management. They can actually greatly facilitate this particular process and help us to generate reports and visualization for easier analysis. Transforming raw data into insights through visualization is a crucial step in data analysis. More importantly, communicating the insights derived from the visualization effectively to the stakeholders, decision makers, and authorities in our own organizations with narrative explanations, annotations, and captions to provide context and highlight key findings is very, very essential to showcase the significance of our services and use of our resources and the performance of our libraries. I am sure this webinar will help all of us to understand and learn the necessary skills on how to input, to track, and unlock the library data and convert it into insights through visualization and make it available to every stakeholder in the organization. Today, we are indeed very lucky to have with us Dr. Vinit Kumar, Assistant Professor at the Department of Library and Information Science at Babasaheb Bhimrao Ambedkar University in Lucknow, who is an expert in this particular field and will share with all of us his wealth of knowledge and experience. And soon after that, I must encourage all of you to get involved in the question and answer session. Before we proceed with the session, I would like to thank our chairman of the Library Advisory Committee at LNMIIT, Professor Subrat Das, for accepting our invitation to be with us today. It only speaks of his commitment to support the initiatives taken by us at the Central Library, which is truly, truly appreciated. Thank you so very much, Professor Das. We look forward to your opening remarks. So, friends, without any further ado, let us embark on this journey of unlocking the library data. And thank you so very much once again to all of you for joining us. And I wish you all a very enlightening and enriching experience throughout this webinar. Thank you. And over to Parini, our Master of Ceremony. Parini.
Thank you so much, sir. Thank you. Moving forward, we have with us Dr. Subrat Das, Associate Professor, Department of Computer Science and Engineering, LNMIIT, who is also the Chairman, Library Advisory Committee, LNMIIT, providing us with some opening remarks on today's agenda. Dr. Subrat Kumar Das completed his MCA degree from Sambalpur University and PhD from University of Hyderabad before joining LNMIIT in 2009. His area of research is data mining and system security. He is currently the lead of CMLBDA, Center for Machine Learning and Big Data Analytics. In the past, he has held different administrative positions in LNMIIT, like HOD, Department of CSE, Associate Dean of Admission and Placement, Chairman, PCC, Purchase and Condemnation Committee, Chairman, IT Committee. Over to you, sir. Sir, over to you.
Thank you, Parini. Good afternoon, everyone. And first of all, I would like to extend a hearty welcome to Dr. Vinit Kumar, who is the speaker for today's webinar, and also to all the participants. And based on the data which I have seen, it is really heartening to see that we have a very diverse group of participants from all across the country. And we all know that libraries have always been bastions of knowledge, serving as vital repositories of information and cultural heritage. In today's digital age, the volume and complexity of data that is available in libraries are growing exponentially. And it is required that this data be effectively visualized, which can enhance the accessibility And also, it will empower all the stakeholders, including the library staff, the researchers, and the patrons, who can glean valuable insights and make informed decisions. This webinar represents a unique opportunity for all of us to delve into the world of data visualization and explore the transformative capabilities of open source software. And our distinguished speaker, I hope, will guide us through various techniques, tools, and best practices for visualizing data in innovative and impactful ways. This webinar serves also as a testament to our commitment to embracing technological advancements and leveraging open source solutions to enhance our library services and better serve our patrons and communities. I extend my deepest gratitude to our esteemed speaker who has generously agreed to share his knowledge and expertise with us. Your insights will undoubtedly inspire us to harness the power of open source software in visualizing library data more effectively. I'd also like to express my sincere appreciation to each participant for joining us today. And it is very much essential from the point of view that it will foster a vibrant and collaborative learning environment. And as chairman of ACLSC of LNMIIT Library Committee, I encourage you all to actively engage in the discussion, ask questions, and share your experiences throughout the webinar. And this will also help us to look into the future strategy that we can have for our library. As we embark on this enlightening journey together, let us embrace the spirit of exploration and discovery. May this webinar serve as a catalyst for unlocking new possibilities in library data visualization and advancing the collective pursuit of knowledge. Once again, a warm welcome to all of you. Thank you for being part of this enriching experience.
Thank you, sir, for those informative words. Next up, we have the resource person for today's event, Dr. Vinit Kumar, an esteemed assistant professor at the Department of Library and Information Science at Babasaheb Bhimrao Ambedkar University in Lucknow, India. He earned his PhD in the highly specialized area of linked data application in library online services and has over 13 years of experience in teaching and research in the field of library and information science. Throughout his career, Dr. Kumar has demonstrated a strong commitment to advancing the field of library and information science through his research and publications. He has more than 30 research publications in international journals and conferences and has delivered over 50 talks as an invited speaker. His expertise in text mining, library online service, open data, research methods, and digital libraries had made him a valuable contributor to the field. Now handing over to you, sir.
Thank you, Arni. And I would like to first of all thank the chairperson of the library committee, Professor Subrat Das, for such a nice words and introducing this particular webinar. I'm also thankful to Mr. Giridhar M. Kunkur for asking me and giving me this opportunity to share my whatever small knowledge I have in this field to the participants of this webinar. I hope I am audible. Yes, thank you. So I think Mr. Kunkur has already uh, put the introduction in front of all the participants. And with this introduction, let me share my slides with you. And I hope you can see my slides.
Sir.
Yes. So basically, the talk is on unlocking library data and the how we can transform the raw data into insights through visualizations. So when sir called me, Kunkur sir called me that can you deliver a talk to the staff of our library? Then I said, what can be like as a teacher of a library science, how I can help the library staff in their day-to-day activities. So I thought, why not I discuss about the data visualization? Maybe they must be collecting some data and day-to-day data of the library, and this will really help them in their daily job. So the I'll start with a quote of David McCandless, and he says that data speaks best through visuals, not words. So basically, the benefit of visualization, what we see, I will start the talk with this particular quote, is that it helps to understand the numbers. It helps to easily comprehend the numbers. And that's what this statement also speaks, like data speaks best through visuals and not words. And we are these days, if we see, we are flooded with a lot of visualizations in any website you open, in any newspaper you open, a lot of visualizations are there. And it is the good tool for a library also, that they start using or they use this data visualization method. So moving on to data visualization part, I will try to first uncover the inquiry process. And why I have put this thing, because I am a teacher, so for me the theory is much important than the practice. I'll come to that part also, but I'll put a little bit theory also here so that it creates a base for the participants of this webinar. So the inquiry process, why we need inquiry? Whenever there is some problem arises, we need the answers, and the answer can get only by the process of inquiry. So I have taken this from the data camp website, and all of you must be aware also that there is a data information knowledge wisdom hierarchy, or can call it as a pyramid also. And it states that the progression from the data to wisdom, why we are doing data visualization. Basically, the thing is that if we try to understand what is data, so data refers to raw, unprocessed facts and figures without any context. For example, 28 degrees Celsius. It doesn't have any context, but it is data. But this raw fact that 28 degrees Celsius is basically uh, acts as a foundation for, if we add some context to it, it can help us in deriving some information, which is organized, structure, and contextualized data, and that helps us in making some decisions. So that forms the information. So when we process data and we put context with the data, like for example, if I put today's date and the temperature together, that can constitute an information. For example, 16th February, the temperature is 28 degrees Celsius. And if I add another data that is in Lucknow, that is the place location, then it forms a full information, like the on 16th February, the temperature of Lucknow is 28 degrees Celsius. So this is how we can now this we form information. So the information can help in answering basic questions like who, what, where, when. Such kind of questions can be answered using information. And then when we add some meaning to it, a lot of information, when we gather together, when we aggregate a lot of information, that constitutes in the concept called knowledge. So it is the result of analyzing and interpreting information to uncover patterns, trends, and relationship. And it provides an understanding of how and why certain phenomena occur, especially when it comes to patterns or trends, when there is something repetitive happening in the society or in your context of your library setting, then we need to have the knowledge. For example, mostly during the admissions, the number of users after the admissions, the number of users footfall in the library rises. Similarly, before the examination, the number of footfalls rise. So what is this? This is the knowledge that you have gathered based on your experience, or you might have collected some data also, and based of that data, you can generate some information, and based of several such information, you have found a pattern that is called knowledge. And the final thing is that when we add uh, some values, some action based on the knowledge, that is called wisdom. So wisdom is very important. Like it helps us in making informed decisions and taking effective action. So I have taken one example from the same website, like this the smartwatch we use nowadays. Mostly people use. So the data part is that the smartwatch collects raw data such as number of steps taken, heart rate, and sleep duration. Then the data is transferred to the app on your mobile phone, and then the smartwatch app organizes and structures the data, displaying it in a comprehensible manner, and such as daily step count. Because see, everyday information is now clubbed, and they are giving you an average heart rate, hours of sleeps per night, like that. And then on the basis of this information, you can analyze it and interpret the information, and find some patterns, such as you have whether you have your steps count have been increased, or it is leading to improved sleep quality, or there is a correlation between heart rate and workout intensity, something like that. And then based on this knowledge, you can understand some patterns also, like to that can help you in making wise decisions, such as you can adjust your exercise routine, sleep habits, and other lifestyle factors. So this is one example I have taken from the website, that is from the life example. Now coming to if we take one example of an academic library. The academic library, the challenge is that students are struggling to navigate the vast amount of information available in the library, and leading to confusion and frustration. Now, we want to ensure students feel empowered to effectively use the resources and ultimately succeed in their endeavors. So, what is the data that the librarian will collect? The librarian will collect data on student interactions with the library resources, like database searches, borrowing patterns, and reference desk inquiries. And this will help in understanding the needs and challenges of the students. Now, by analyzing the data, the librarian will identify trends and areas where the students might need support. Are there specific database causing difficulties? Like what? Yeah, which databases? Are certain topics missing from the collection? Based on their patterns on references inquiry, we can analyze this. Do the students need clarification on effective citation management? This is one example. So these kind of information we can draw. Then by interpreting this information, the librarian gains valuable insights about the issues of students. Then she can use this knowledge to develop initiatives that can improve the library experience. So based on this knowledge, the or the we can say insights, she can implement strategies to actions. Means she can change, she can take informed actions, or she can make strategies to specifically enhance the resources and services, like in terms of curating the resources that are directly catering the needs of students, arranging some targeted workshops on database searching, critical thinking, citation management, and other essential skills. Some personalized consultations also she can schedule, like individual consultations to the specific users, and showcase lesser known library resources and services. So by employing a data driven approach, the library can provide targeted and effective resources and services to their clientele. So this is the whole thing, that DIKW hierarchy we have to understand. So always whenever some decision we want to make, we have to start thinking what kind of data that will help me in making this decision, X decision that I want to make. And we have to start collecting the data and then converting it to knowledge, information, knowledge, and then wisdom. For further reading, I'll share the slides also. I have put a link to an article here. You can read in detail about this DIKW hierarchy. So as I discussed, the steps in data visualization is selecting and or collecting the data. Selecting here, I mean that, as Mr. Kunkur also mentioned, like if we have a collection of already managed data collection, managed collection is data is also already available in the library. Just we have to select the data which we can take to analyze or to prepare the visualizations. And then the second step is that cleaning and transforming data. We have to clean the data also. We have to see whether the data has some errors are there, some omissions are there, or some actually the things which we want to analyze, whether they are available in the data or not. So that this step is very much important, especially if there is a case of a textual data. And then the final step is that we analyze the data and generate visualizations that helps us in getting insights. So before we moving to the data visualization, let us first understand what is data in detail. So the this process, if I ask you one question here, what is the most important part of an inquiry process? Whether it is collecting data, the looking at the data, running statistical tools, and deciding which statistical test to apply. I think the answer will be mostly people will say that the collecting data is important part of inquiry process. No, the actually the most important part of an inquiry process is looking at the data. We have to see and analyze we have to feel the data. We have to first understand the data that we have collected. So if we are not able to understand the data properly, we cannot do proper analysis, we cannot generate good visualizations. So why it is important to looking at data? Looking at data helps us in gaining a clear understanding of the variables and the values they are taking. For example, whether we have high values or whether we have values which are very uniform in nature, whether there are extreme values available in the data, that we can understand by looking at the data. It looking at data also helps us in choosing appropriate statistics. I will discuss later also like what are the different types of the levels of measurement that we have, and based on which we can further apply a statistical analysis. But I am not going in detail in this webinar because statistical part I am not covering here much. Then we can also identify possible problems in the data and gain descriptive information. What are the means the problems are, we can identify the problems, whether the data is not complete or whether some missing parts are there, that we can find out. We can also by looking at data we can set clear objectives. Clear objectives, what I mean here is that by having clear objectives, clear you can easily set your objectives looking at the data, what can be achieved from the data set that you have collected and what cannot be achieved. So sometimes like for my students, when I guide for them for PhD, they take out something which is not available in the data, they give results which is not available in the data. So the looking at data helps us in finding what is the actually we can achieve by the data which we have collected. Then the looking at data helps us is cleaning data by removing anything which is irrelevant, or if something some sections or some data points are missing, we can use correct them. And if there are some erroneous entries, we can remove them and correct them. That is possible. Then it also helps us in looking for patterns and trends in the data. So patterns and trends are very much important. It gives you one kind of a kind of a signal that can help you in further applying statistics. So data, if we come, it is of two types: qualitative data and quantitative data. Just I'll go through some definition. Qualitative data is non-numerical information that describes the characteristics or qualities of an object, event, or phenomena. This type of data is often subjective and used to capture qualities that cannot be measured with numbers, such as colors, like red, blue, green. We cannot measure colors in terms of numbers. Emotions, yeah, types of fruit. Here, the types of fruit is a qualitative data because here it is a name of a fruit: apple, banana, orange, like that. Then quantitative data on the other hand is numerical information that can be measured and expressed with numbers, and it provides a way to quantify and compare the characteristics being studied. So we will see both kind of some visualizations which we can create for both type of data we have. So for quantitative data, examples are like height 165 centimeter. It has number, temperature 25 degrees Celsius, number of students in a class 30, 50, like that. So if I ask you a basic question, like if a researcher is studying the impact of a new teaching method on student performance, the researcher collects data on whether the student feel more engaged in the classroom, Whereas is the data in this scenario is qualitative or quantitative? The answer will be qualitative, because here the researcher is trying to study the impact of a new teaching method. So impact of a teaching method, if you want to measure, so we have to collect the qualitative data. There are ways where we can collect, where we can convert qualitative data into quantitative data. So for example, here the researcher wants to study the engagement of the student, and engagement can be measured by qualitative measures only. And in the second, this one, the a survey asks participants to rate their satisfaction with the product on a scale of 1 to 10. So here the satisfaction is again a kind of qualitative data, but the the qualitative data is converted to quantitative data in form of numbers by using a scale, that is 1 to 10. So this is again a kind of a quantitative data. And similarly, an anthropologist records observations about the daily routines and social interactions of a remote tribe. In this ethnographic study, what kind of data is the anthropologist collecting? The anthropologist is collecting daily routine. He is observing the tribe, their social interactions, observing. So here the data is qualitative, because the daily routine cannot be expressed in the form of numbers. So the qualitative data is basically divided into three types: quality, nominal data, ordinal data, and binary data. Binary means they will have two values only, two values possible, like yes or no. And a nominal means just number, we give a particular name, but no ranking is there. For example, gender, male, female. And in quantitative, we have two types of data, that is discrete data and continuous data. So discrete data means the values are always in a form of a finite number. So like counts data. There can be like, for example, the participant number of participants in this webinar. They can be always a finite number. It cannot be in fractions. So that is an example of discrete data. And continuous data is that can be measured on a continuum or scale, means the between values are also available, like length, size, width, etc. Similarly, we have the levels of measurement of data. Like we have four levels, that is nominal level of data measurement, ordinal scale, interval scale, and ratio scale. So nominal scale means that very simple kind of data. We cannot do much analysis in that, except we can do only frequency distribution. For example, the types of user in your library. So the types of user in your library is just a nominal data. Or the subject your collection has. What are the different subjects your collection covers? It is also a nominal data, because nominal, as its name suggests, nominal means for the sake of name only. So in that the table also you can see that the distance between successive numbers is not there, interval is not there, 0 point is not there. Only the like, for example, gender and social class is a kind of the nominal data. And you can just calculate the frequency other statistical measures or statistical this one. And then the ordinal data means that there is some order is involved. The data has some order, means the sequence is there. Like first, second, third, fourth is an ordinal kind of data. Or if we like, for example, we give star rating to services and products. When we put reviews, though these star ratings are nothing but a kind of ordinal data, because if you give 2 stars, which means that and if somebody else gives 4 star, which means that they have given 2 times more ratings to the product. So similarly here, the ordering is there, but the distance is not there, and the interval between the successive rank is not equal, and 0 is arbitrary. Like, for example, here the shoe size or the battery they have given. So what we can do here, maximum we can calculate medians, and we can calculate percentiles, and frequency distribution is possible. So if we are having ordinal data, we can perform only these two operations. Then comes the interval data. In interval data, we have the ordering is also there. For example, 1, 2, 3, 4, 5. There is an interval of 1, and then the distance is this distance between each data point is equal, and the intervals between successive rank is also equal, that is yes, and 0. But here the 0 point is arbitrary in interval data, like temperature, IQ. The 0 point is man-made, it's not actual real 0 point. And the final data, in this interval scale, we can measure frequency distribution, median percentiles. We can perform other operations like add and subtract. We can add two values of a particular this one interval data, and then we can also calculate mean, standard deviation, standard error, and like that. And then, but the ratio and coefficient is not possible in this. And the ratio data, that is the that is called the most useful data in statistics, is the that you can, it has the ordering also, it has this equal distance, and the equal distance, and the interval is also same, and the but the 0 point is also absolute, means the real 0 point exists, like age and weight. So these are like citations, this or number of this one books. You have the age and weight also. So in this you can calculate the different mathematical operations you can do, statistical operations like frequency distribution, mean, median, and percentile. You can add or subtract. You can calculate mean, standard deviation, standard error of the mean, and you can also calculate ratio or coefficient of variation. So why this slide I have put here? Because we have to understand the data first, and then only we can decide what kind of final output we can generate from it. We cannot collect nominal data and generate output which is relevant to ratio data. For example, if I collect only the names of the participants in this group, in this webinar, I cannot calculate mean of that. I cannot calculate standard deviation of that. Okay, so we have to understand the variable what we are collecting and what kind of data that variable has. Coming to the different types of data. So data has different types. First, I will talk about unstructured data. Unstructured data means data is not divided into any fields, or it cannot be comprehended. The data cannot be comprehended easily by the computers. For example, your email. In your email body, if I write something, and if I ask computer to extract a particular part of it, the computer cannot extract. Similarly, for example, a PDF file or any word processing document, or, or cannot be processed by computer directly if I ask to have some part of it extracted, some part of it. So unstructured data is very like useless for the part of a data visualization. So we need to convert into structured part so that we can further perform operations on it. Another format that is called semi-structured means some structure is there, but that is also not so much useful. For example, HTML, all the tables will be having table tag, and all the tables will be inside the table tag only. If you are aware about HTML, then it will be not much helpful to extract a particular table from HTML. So it is, that is why it is called semi-structured. And the final is that is called structured part. Structured part means the data means that the data is divided into different fields and stored in a database. So when it can be a file based database also. So it is stored in a database means in the form of fields and subfields. And now it is easier to extract, for example, if in an Excel file. So if you have data structured in terms of columns, and every column has a header, then you can easily ask computer to extract the first cell of the first column. Easily it can extract. So that comes under the structured part. These are some of the other examples of data types, like structured data. We have seen unstructured data, geographic data. Mostly it has the language, latitude and longitudinal, this one, information. Real time data that is fetched from the some equipments that are generate data in a real time. Natural language data means textual data. uh, these days a lot of natural language processing, text mining, and popular. We are seeing a lot of applications also. Then time series data means the data is on the basis of time that has been created, the collected on the basis of time. Event specific data, network data, when we have connection between different types of entities and their relationship, that is called network data. This data we have already seen in the case of citation analysis or bibliometric analysis. We use a lot of network data. And in libraries also, a lot of applications can be made with this network data also. Then linked data is an application of semantic web, and when the entities from different data sets, data stored at different places on internet, are linked with each other by using common identifiers. So a lot of numbers I have given you, numbers. So the problem is that the people we are trying to convince are often the people who have least time to dive deep into complex data and interpretation. So in the beginning, like Mr. Kunkur mentioned about like we have to convince the authorities. Yes, but if you try to convince them with the help of numbers, they will be least convinced, because they do not have time. They cannot. That's why you see in the scientometrics or bibliometrics, a lot of indicators have been developed, like impact factor, H index, something, because the authorities do not have time to read your whole lot of 30 papers or 1,100 papers people have. So they cannot read all 100 papers. They need a number, a particular figure or visualizations, an indicator, so that they can analyze the quality of a researcher. Similarly, here also we have to understand that the people we are trying to convince are often people who have least time to dive into the complex data and interpretation. And they are often outside of the library world also, because if you go to authorities to ask some money or some resources, they will be not aware of what you are doing in the library. So you need to convert your data into a thoughtful and easily comprehensible display. And to translate, and also you have to translate data into a convincing argument by providing proper context. And so basically the aim is to convert numbers into a persuasive story, so that we can pursue the authorities in our whatever we are thinking to implement. So data visualization helps us in this. It is an art of converting data sets into simple graphs that brings out unseen patterns and connections. And usually it is effective in the large data set, where because for example of a table of 100 rows, I think human can easily comprehend. But if the data is more than 1000 or 10,000 or 1 million rows, it will be difficult for a human to comprehend it. So in that scenario, we need to have data visualization. So that helps us in understanding the data set quickly. The primary objective of data visualization is to gain insights, that is hidden truth, uh, from the data or the information. So generally speaking, the graph is an effective way of communicating data when precise numeric details are not required. So if particular numeric details are not required or specific details are not required, we can use the graph. But for example, in research studies, we cannot just rely on the visualizations. Even in libraries, if I say, you have to maintain your numeric data set also along with the visualization. Okay, you project the visualizations, but keep the data, that backend data also, so that you can further, if somebody asks, you can present them. So visualization can be effective when in the case when we want to communicate precise numeric details are not required, and a trend or comparison can be demonstrated. We want to understand a trend, or we want to compare something. then these are useful. Or if want to, if and there is also, there should be a relationship between the data values also. Some kind of relationship should be there. Some kind of relation should be there when we want to create visualization. So if you are collecting some data which do not have any kind of relationship, it will be difficult to visualize them properly. So this is one definition from University of Michigan Library that defines visualization as a good way to help people interact both with the data that we have and the data that we can help people find. And the same thing, it is mentioned that patterns, trends, and correlations that might go undetected in text-based data can be exposed and recognized easier with information visualization software that we will see. And then it addresses a complex problem that could be easily looked over and simplifies it using design. So merits, we have already seen a picture is worth 1,000 words, especially when you're trying to find relationship and understand data. Then creating charts and infographics can be time consuming, but the visualization tools can make it easier. We will see some of the tools also, because without software, it is difficult to create visualizations. Then draw attention to the critical message quickly by presenting information visually. And it is also possible to uncover unusual patterns and observations that would not be apparent from looking at stats alone. For example, you want to see, say, for example, you are automatically collecting something, and you see that in the night 11 o'clock, some logins are there in your screen, in your library. Some people have checked in or entered. Then that kind of things can be easily looked up using visualization. So visualizations are basically two types, broadly if we see. First is called explanation based visualizations. So they basically helps us in presenting the crux in understandable and comprehensible manner. So we want to just explain what is going on. And the another is that is the exploration based that visualizations helps us in understanding the crux that is hidden in the pile of figures. So crux means the, the typical value or the typical trend, something that we want to explore. And there are basically two basic categories, and the three types of data that we will discuss also, 1D and 2D and 3D data sets. Then the next is that we will discuss about different types of data graphs. For this particular webinar, I have selected the common ones: histogram, frequency polygon, ogive, stem leaf plot, and then qualitative data graphs. Also, we will see two data graphs: pie chart and bar chart. So quantitative data graphs are those data graphs which are plotted against a numerical scales. Means the data that is collected is basically either the interval data or the ratio data. And the qualitative data graphs are data graphs which have nominal data, non-numerical one. First is that is histogram. Histogram is it's a type of a graph that represents the class frequencies in a frequency distribution by vertical adjacent rectangles. So for example, these are the average circulation of a per day of a particular library. And if we want to visualize it, we can see that the say for example, this is the week, first week, second week, third week, first day, second, third day, fourth day, fifth day, sixth day, and seventh day. So we can see that mostly, or most, the number of times these circulations, the higher are the 7.2 history book issued in 40 weeks. So higher are the values that are having circulation on an average 7.2 circulations in a week. So this is a histogram that with the help of bars, vertical bars, we can see we can show the particular variable, and this is used for only one variable. So for example, I want to, here the books issue rate is there, or anything, any other variable we can take. Then next is that is called, in this case, we have to first generate the frequencies, class frequencies for a particular this one and their distribution. So next is that is frequency polygon. Frequency polygon basically is again a kind of a class. We are displaying the class frequencies, and each frequency is plotted against a class midpoint along a horizontal axis and the frequency scale along the vertical axis. And changing the scales of the axis can compress or stretch a frequency polygon, and which affects the user impression of what the graph represent. So this is again this fact I have what here I want to mention, that some people they lie with the graphs. So for example, if I just extend the midpoints here, it can be a almost flat graph also if I extend the classes. So this is very much important to be honest with the visualization for the audience which you are making. Then next is that is ogive. Ogive is a cumulative frequency polygon, and on the x-axis the class endpoints are there, and on the y-axis the cumulative frequency is plotted. For example, number of books issued in a month, say for example here. So on the first day how many books are issued, second day we add the values here. So so that we see the trends, whether there is a steep growth, or what are the different different uh, the exponential rise or the steep rise is there, that we can easily find out. The steep slopes in an ogive can be used to identify sharp increases in the frequencies. And next that is I have taken is dot plot, a simple statistical chart that is generally used to display continuous quantitative data. In the case of quantitative data like 2.8, 4.2, in between values are plotted, and every data points indicates a one particular value. So if there are more value, which means that those values are more in the data set. So if you want to see, for example, here, if the same data we have, the circulation rate, then we can see that the more data is there in the 7.3, around 7.3 or 7.5, more data is gathered here, and less data is available this side and this side. Dot plots are is useful for observing the overall shape of the distribution. What is the shape of the distribution? Whether the distribution is bell shaped or not, or whether distribution is skewed in nature. Then the next is that is stem and leaf plot. It is another way to arrange raw data into groups besides using frequency distribution. Frequency distribution, we have seen that we convert the number of times that data in the data set and calculate the frequencies. Here we that is one method. Here by using stem and leaf plot also we can do the same. And say for example we have the following raw data here, and then we can draw the stem and leaf plots. So say how we do that. Say for example the value 2, 23, 2 is the stem and 3 is the leaf. 39, 3 is the stem, 9 is the leaf. So likewise we take every data value and put it in the stem and leaf format. And now we can say that more values are there in the 6, 7 and 8 stems. Means more values are there in 60s, 70 and 80s. Rather than counting the frequency, we see the size of the leaf. Then coming to the qualitative data graphs, pie chart and bar chart. Pie chart is a circular depiction of data where the area of the whole pie represent 100% of data, and slices of the pie represent a percentage breakdown of the sub levels. So it shows the relative magnitude of the parts to the whole. So it is used to show relative data and to make comparisons. For example, budget categories, market shares, time and resource allocation. For these things, we can use the pie chart. But pie chart is regarded as the is not a good visualization, because it does not represent the total value, but it represents the relative value. Means in comparison to others, what is the particular value is there. So basically the whole data is converted into 100%, and then slices are cut out of the 100% based on the value of each data set. So that is the problem here, that we by seeing at a pie chart we cannot ascertain the actual values. So one example I have given here, for example, the allocation of in lakhs for books, journals, general books and book bank. And we can easily plot a pie chart by, usually in the pie chart slices are there as I mentioned, and the maximum slices for the books, because it is 8.2 here, And the whole thing is, the process is that we take the total and consider total as 100% or 360-degree, and then we cut slices based on the individual percentage value of the particular x variable. So here, for example, the type type value is 8.2, so we will multiply it by the total percentage and then multiply by 360-degree, and whatever angle we will get, we'll cut the slices based on that. Next is, that is bar chart. Bar chart or a chart contains two or more categories along one axis and a series of bars, one for each category along the other axis. So these are two-dimensional as opposed to one-dimensional histograms, and the length of the bar represents the magnitude of the measure of each category. So in Excel, you can easily draw bar chart. Horizontal bar charts are available, but vertical column charts are available, and it has easier interpretation than pie chart. For example, here the same data is there, but we can see that the books have higher allocation in comparison to others. Here also we can see the magnitude also. So because here, if you see, the values are plotted on the base of x-axis or y-axis, we can change the axis also, and we can easily see the exact value that has been allotted to books. But in the case of pie chart, we cannot see the exact values, that are exact magnitude of the values. So that is this is bar chart. And there is one in Excel, you can calculate some compound bar charts also, means you can mix up several values together and generate compound bar chart. So data visualization methods, basically there are several other types of data visualization methods that are available, especially like if we see the two-dimensional data sets, area map type information visualization. It is usually geospatial in nature, and three-dimensional volumetric type when we want to show some volume, especially in the case of scientific visualizations such as 3D computer models, surface and volume rendering, computer simulations. In that case, we can have different other types of visualization also. So by having knowledge of the different types of data visualizations, we have also understood the types of data types, and also we have understood the levels of measurement and the two types of data. Now coming to the qualities of a good data visualization. So the Albert Cairo, he has proposed 5 qualities of good data visualization in his book, The Truthful Art. And in his book, he proposes a 5-part framework to evaluate the qualities of a data visualization. And he says that a good data visualization should be, first, that is truthful. It should be truthful in the sense that it should seek to be honest with ourselves and our audience. So while creating the visualization, we see graphs can lie easily. They can lie. I can show several examples where the graphs are not properly made and they are specifically telling lies. But we have to be honest with ourselves and our audience, then only it can be called a good data visualization. Second quality is that it should be functional. Functional means the purpose why you have made the data visualization. It should solve that purpose. It should help the audience interpret the conveyed information. It should be not like so many information you have burdened, put it there, that it increases the cognitive load, and the audience for which you have prepared the visualization, they cannot interpret it. Because we have to remember that in the beginning, why we are making visualizations. We are making visualizations so that the big data or the data that we have in the form of numbers, we want to show it in the form of visuals. But if the visual itself is so much having cognitive load, so much requires so much efforts, it will not be called a functional visualization. So it should your audience should be able to interpret the conveyed information easily. Then that is the quality of a good data visualization. Then the next is that is it should be beautiful, means it should be pleasing to your eyes. It should look good. And because at it I said that picture is worth 1,000 words, but the picture should be like that. It should be a little bit beautiful, but we have to resist ourselves by putting excessive elements, so that because it can be distracting and it can obscure the interpretation. If you put a lot of colors and lot of things in the this one in the visualization, so it may distract the audience and it may obscure the interpretation also. So we have to think of like we have to make the balance between we have to also see whether the data is functional and the visualization is functional, and also see whether it is beautiful or not. It should be good looking also. It should be insightful also. Insightful means it should generate insights inside the mind of the reader or viewer. So there are two types of insights: spontaneous insights and knowledge building insights. Usually spontaneous insights means the insights which are easily ascertainable from a point of view by a normal reader or viewer. And the knowledge building insights means by interacting with the data visualization, the the viewer can easily find out or they can build some knowledge out of it. For example, here I have given one link to one of the very interactive visualization. Interactive visualizations is making it interactive visualization required little bit of program knowledge. For example, you can easily generate interactive visualization in Python or R, some software. But here I can show you how good it is to see interactive visualization. So this article basically from Scientific American, in it says that how nations fare in PhDs by sex interactive. I think my screen is not visible, right? Let me share it again. Okay, I'll make it entire screen so that it will be some issue is there, no problem. I'll just, so can you see my screen? Yes. So here you see this website. This is very interactive graph. You see here the user can select the all PhDs or a particular year, non-science PhD, all science, engineering, agriculture, like that. They can select a particular subject from here, so I can interact with it. And the female, male, all PhD lines are visible. And here different countries data are available. I can also select a particular uh, country also, like ascending percentage of females region wise if I want to sort it, or the some gender gap data is there. On the basis of that, if I want to see, so this kind of interaction is there. So user has to interact it with it, and they can ascertain the values from the this one. So this is one example of knowledge based visualizations. And then it should be enlightening, means it should shed light on a particular topic of interest. It should give some information. It should be enlightening, means which is not known to people, which is not uh, means something which was in dark and you are opening it. That is why the title we have put it for this webinar also, unlocking library data. Means you are enlightening it, you are opening it, and it should shed light on topic of human interest. So these are five important qualities of good data visualization. Some problem is there. Let me again share. Shubham, when I share my screen, it says that some error is there. I'm
Uh,
already sharing. Okay.
yes, yes. Uh, you cannot share your screen, sir?
I think now it's okay.
Okay, okay.
Mhm. So coming to the library data, what kind of data we have in library? We have a bibliographic data like catalog data, the kind of books that we have, the reading material we have in the library, their bibliographic details are there. Then we have transaction data like the circulation data, book borrowing record data, and other kind of transactions, whatever the library has, that data is there. And then we have usage data, especially in the case of e-resources, usage of services of library or e-resources or some like website or institutional repository or any other service that you have. So that usage data will be there. So we can make the decisions based on this data by data visualization, like retaining of the resources, subscribing, unsubscribing to new resources. Like manually studying the usage of library resources is tedious, but the data analytics process is effective in producing insights from the library usage, and visualization techniques are efficient to summarize big data. Sufficient information to make right decisions about which kind of books they are going to purchase, what kind of magazines have to be ordered in coming renewal period of the year, what type of e-journals to be renewed. These kind of decisions can be made. Data sources such as transaction logs. Transaction logs basically are available from the websites or from the vendor of the databases. We can get that circulation data, interlibrary loan transactions, reference transactions, and more can be mined for information that reveals user behavior and enhance the value of library collection to users. From the circulation transaction log, it is possible to get fast moving titles and slow moving titles, which is beneficial to make future decisions regarding acquisition of documents, like which category of users are accessing their services, which collections of resources are accessing, and how digital library services can be improved to better serve the users. So such kind of decisions can be made. So this is one example that this I have taken from a book that says that common website traffic of for institutional repository. What are the different uh, common data that we can collect and what kind of insights we can generate? So temporal data means number of unique visitors over a year, month, day, and hour. If you want to say who are the unique visitors, number of returning visitors over year, month, day, and hour from any institutional repository or any service, particular service, we can have this data. Duration of visits, how much means how much duration they stayed on the website on the particular service. Similarly, for content related data, we can have like what file types they have accessed, What are the entry pages and exit pages used by visitors? This is very important for understanding the landing pages, means where the users are first entering on your website. Then visitor data, also top 10 countries of visitors. You can analyze identification of robots and spiders visiting website, which spiders and robots are visiting your website. And even if you don't like some of the robots, by using this information you can block some of the robots or spiders also. Then what kind of browsers people are using, from which operating systems mostly they use, what kind of screen resolutions they use. So these kind of transaction data is available from transaction logs. Then referring search engines, because these days usually people come from search engines. So which search engine has referred to your website, what are the different keywords that and phrases searched that led to that visit. These you can easily analyze. And then troubleshooting data, like what are the different http error messages encountered by users accessing the website. And by users accessing the website, then identify pages not found by visitors. Some pages you can see what kind of pages users were looking for and they were not able to find out. So such kind of information you can generate. Other some visualizations also I have put from different books here. For example, you see here, one the visualization is the 24 by 5 services launch fall 2007. This is the data of 2007. And this row is for maximum, how many users were there. So maximum around 270, 260, 70 users are there. And this is the average value and this is the minimum value. So you can see that during the night to 12 o'clock and since morning, the head counts are decreasing. Similarly here, average attendance, walk-in attendance by day of the month, you can create such visualizations also. So mostly people come on Monday or Friday, on which day people usually come. And then similarly, you can, one graph is there that show website visitors per year, whether they are increasing, decreasing, and whether there is shortfall that you can analyze. Number of queries, the average of 1977 is this one, the 1998 this line. So you can compare whether the number of queries you have increased, and you can show to the authorities also that we are improving, like in comparison to previous year we are handling more number of reference queries, something like that. Here also the transactions by hours, like in the 8 a.m. to 9 a.m. period, what kind of transactions are happening. Then 9 a.m. Then you can easily see that more transactions are happening in the 11 to 12 p.m. So you can depute your staff here. Extra counters can be installed or something like that. You can take decisions based on this. And this is also Monday, Tuesday, and on day wise also is there. So a lot of this one is there, but on Sundays there is a more footfalls at after 1 o'clock, transactions after 1 o'clock, and usually at the time of 6 to 7 p.m. So these kind of decisions you can make, that on during weekdays you can put your staff in these hours more, and then on Sundays you put more staffs here. Similarly, the total number of transactions that are leading reference transaction. For example, here the data is what is the duration, 0 to 1 minute, 1 to 5 minutes maximum. The maximum transactions are 1 to 5 minute, and the minimum transactions are 10 to 30 minutes. I mean, very few people are there who take more than 10 minutes time in the reference transaction. Similarly here, the transactions, and you can have comparison from the previous years using bar chart. So you see here for the week of the semester, first week, second week, third week, fourth week, sixth week, and then you have in the previous year what was the transactions, what was the number of transactions, and with this you can easily show the comparison that like the transactions are increasing every year, and the data values are also shown in this visualization. Similarly, faculty transactions, Sunday there are very few transactions, and mostly Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, and there is a decline. So you can have more faculty transactions are there, and similarly, if there is some decision, you can take undergraduate transaction. Also, this visualization shows the total number of transactions in a week. Here, total annual issues per year, annual number of books issued here, and this pie chart, it shows the color with the help of color: fiction, non-fiction, and junior. So these are three category of books that are issued, and for every year it has been shown here by using a separate pie chart. Means multi pie chart, multiple pie charts are used to display the or to compare the characteristics of annual issues uh, based on the different types of documents or types of books here. So such kind of visualizations can be made. Here you can see another one, like the type of the subject category, like robotics, business, psychology, and there's high priority, critical, medium, and low priority. So in the robotics or psychology, high priority demands are there. The authors are usually requesting the books which have high demand, high priority. Similarly, in critical priority, we can see software and business books are mostly critical, and the authors or the users have put them in the critical category. So something like that you can also create. I'll show you this data I will show you how to create such visualizations. And this is also kind of a dendrogram here, like for example technology, this the number of books or the collection size, you can show it like that in the technology subject. And in the sub subject like robotics software, we have more collections in the robotics and software in comparison to computer science and mathematics. Similarly, in social sciences, we have more collection in psychology and sociology in comparison to education and arts. For management business, we have more collection in comparison to others. Like that also you can show. So now I will discuss some free data visualization tools that are available. And just I have given here the links on the slides, and then you can figure it out, and also a screenshot of the this one, every website. So Candela, this is again a kind of a open source suite for web visualizations, and it is used for making rich visualizations. So this is a good, this one you can use. It uses JavaScript. Most of the visualization software these days, they uses JavaScript. Then chart blocks is there. uh, from spreadsheet to graphics, we can create a lot of graphics here. And then charted is another one that is also free. We can use it. It is developed by Medium people. Medium is a famous website that maintains the like a website of computer science related stuffs. And then chartist.js, this is one library package that is JavaScript based. You can install it in your website and then generate a dashboard like templates or dashboards you can create with the help of this if in your website. So, and you can create visualizations, interactive visualization using this. Then color beaver, this is basically for geospatial data. When we have the geographical or this map based data, cartography based, then we can use this. D3, this is very popular JavaScript library for data visualization. It is said that if you know D3, you can do any kind of visualizations. And most of the tools that we see, they are basically in the backend, they are built on top of this D3. So D3 is another kind of, it's also an open source library that you can install it on your server and then create different visualizations. Data wrapper, a website where we can upload data and then generate visualizations on data. This I will cover a little bit while. And then this is one example that we have generated. I have generated from data wrapper. Gephi, some of you might be aware also. This is for visualizing network data, especially. So if we have a network kind of data, then Gephi can be used. It's a very good tool to visualize network specific data. Looker Studio is from Google Studio, Google, and it is basically used for developing dashboards. Means where you want to create is interactive visualization, as well as you want to create visualizations which are generated on the basis of real time. So in the backend, you provide a data source, like you see here. You provide data source, and then you create reports based on that data source. And in the reports, you can put different type of visualizations. And whenever the data source changes, the visualizations changes automatically. So especially for making dashboards or for making visualization on a particular website, this Looker Studio can be useful. Leaflet is another type of JavaScript library, and that can be used for especially for the purpose of interactive maps. And this library is also mobile friendly also. So responsive mobile friendly interactive maps can be made easily. Palladio is again another kind of network visualization software. It is developed by Stanford, and uh, you can, if you have network data, you can easily generate visualizations with that. Paraview is another this one visualization engine. Plotly, basically for data visualization, especially if you have knowledge of Python, you can use this Plotly for data visualization. And it has Plotly has a website for dashboard also, that is generated by using Flask library. Then Polymaps, this is based on JavaScript image, and this is also a good library. Raw graphs, this I will cover afterwards. This is also a free open source library, and it's also JavaScript based. Some of the paid data visualization tools are like Tableau, Zoho Analytics, Microsoft Power BI, IBM Watson, IBM SPSS Statistics, and some Dundas BI. And in Tableau, if you have you can, if you are academician, they give 1 year free license also for Tableau. And Microsoft Power BI is paid for this one. On all the others are also paid. So for using these data visualization tools, you have to pay money. Then if you have a textual data, you can generate word clouds, or it's not world cloud, it's word cloud. It's a typing mistake here. So word clouds can be generated by using these websites. These are all free website creators. One I will try to show if the time permits, wordclouds.com. So this I have generated from wordcloud, wordcloud.com. This just one paragraph from, I think, one of my papers, and it has generated a visualization of a word cloud out of it. So I think I can stop here, and then I can show you some demo of the raw this one. So let me share this part. Okay. So if you open this website rawgraphs.io, and this is very it's open source also, which means that you can generate the visualizations on this website also. Or if you do not want to upload your data on this website, like sometimes the particular authority or institutions, they do not like that you submit your data to some external website, then you can also install this on your server or any PC, and then you can run it, and you can generate visualizations. So it's not like you have to generate your data here only. You can generate it by installing in your website. So GitHub page they have given, and they have given the instructions also how to install it. So I'm not going to going in that. Just I want to show you some visualizations that they have given. So for example, issue books here, issue mapping of an aging Europe in seminal guide to mapping social and political issue with digital methods, the issue at stake concern the, like this is one example they have given, and it has a very nice gallery also. You can see such kind of visualization you can generate using uh, this one. This alluvial maps you can generate. Year-wise alluvial maps are available. So such kind of visualizations can be generated. So what I will do, I will click on use it now, and it will lead me to a page where actual this application runs. And here I can either paste my data here, and either or I can upload my data. So for this demo, I have taken one data. Let me upload it from here, and then I'll discuss what kind of data it is. So basically it is a kind of data where faculty has requested the library to purchase some books, and faculty of an institution, and the institution, the books have been ordered by the library, and this is the final acquisition data that we have. So the order ID column represents the author order ID something, then the order date is there on which the order was made, and then the receive date when the order was received, and based on which the I have calculated the delay, means delay in days, number of days from the order date to the receive date, and then the campus of the particular institute. So for example, it has Lucknow campus, Chennai campus, Hyderabad campus. And let me tell you that this is a dummy data, it's not a real data. So don't take it as like it's a real data. Then some faculty ID is there, faculty name is there, and the city, publication country, and the vendor state, the vendor which who has provided the data, the book, then the call number, uh, then the subject of the book, then sub-subject means the subcategory, sub-subject of the particular book which it belongs to, then the book price, then the number of books, that is quantity, the discount in percentage means for example, this has given 15% discount, this particular book has been ordered in 15% discount, then book cost, actual cost, this data is ratio data, and this is also a continuous data. Shipping cost, what was the shipping cost and the total cost. And there are two other categorical variables, that is order priority, whether it was a critical or high priority order or medium priority order, and then shipping mode, from which mode the book was shipped, by Amazon or Flipkart or courier or speed post, something like that. Four categories are there. So you have to create your data like this and upload it as a CSV file. CSV file is a type of file which is actually comma separated value, means the values are comma separated, and the first line of the file should have the headers, for example here. So it automatically, when you upload the data, it automatically detects the type of data. For example, A here, A means the particular variable or the data type is a categorical data. And then for in the case of date also, it has automatically detected. If it is not detected, you can click on this and click on the like you can change the type of data type. For example, here it is date. If I want to change it to number, I can change it. And if even if the date format is not specified, I can change the date format to some other date format. So here this is fine. This is fine. If it is not there, you can do it. And then you can also sort the data based on a particular clicking on a particular field. Now we have uploaded the data now on the website of apps.rawgrass.io. Then the next step is that we have to select a chart. We have to choose a chart. So a lot of charts are available. You see, these are alluvial bar charts, and for each chart, if I select, they provide a scope note also. They provide when you can use this particular chart and what it actually displays. So it shows collect correlation between categorical dimensions, representing them as flows, usually linking categories with shared items. So here, if you want to use alluvial diagrams, these are basically used when we want to show some kind of flow in terms of, like for example, in this graph you see A is now distributed to is now half of A is going to D and half of A is going to E, and B is also half of B is going to D and half of B is going to, means there should be some shared items between the variables, and if the shared items are there, then you can use alluvial diagram. Similarly, you can use multiple set bar chart, multiple quantitative dimensions related to categories. You can use stacked bar charts if you want to show some correlations, and then bubble chart, correlation plus proportions, chord chart if you want to show some networks or diagrams. So whenever we select a particular, say for example, if I say bar chart, when I select a bar chart, the next step is that I have to specify the different dimensions that I want to include in this bar chart. So say for example, I want to see the uh, subjects. So I put my bars here. So here asterisk means this is the mandatory one, and I can now come down and I can see that I have the management, social science, and technology. Three subject categories are available. Means the faculty of three subjects have asked for books or requested books, and then even I can further show the size of this also, size dimension also I can put. Even I can put a series also, but in this case I am not going with that. For I'll just change only the color. I'll color based on the CSV value. So for management different color, social science and technology different color is there based on the different categories that is available in this particular dimension. The color has been shown, and now I can, next step is I can customize it. Customize in the sense I can I can increase the width of it. Say for example, I want it in 1200 pixel multiplied by 980, say 720. So I have the 720 and 980 width. This one I can specify. I can change the background color if I want some other color, that also I can make. So a lot of customizations I can make from here. Similarly, chart-based customizations means bars are vertically or horizontally. If I want, I can make them this one. And then series, we do not have any series here, but I can this one show series grid also. If I want, I can do. Even colors also I can change. Some 2-3 colors are available. I can change the colors also, like this color. And once we have done with the customization, we can export the visualization, and we can export the visualization in 4 formats. One is that is SVG. SVG is the vector graphics file, which actually maintains high graphics, and it can be visible in on the websites also. It is good for websites also. Then PNG and JPG is quite popular. You must be aware. PNG has a smaller file size, where JPG has a little bit more file size, but the quality will be better, more compressed will be there. And raw graphs means you can store them as a raw graph, so that if you want, you can further change them. You can further edit them on the basis of instructions that they have given. And if I click on this and choose a particular name, I can click on download and the file will be downloaded. So say I download it in, so the file will be downloaded and I can open it in my, I can see and use it, this file. I guess it is not visible to you because I'm not sharing that particular part. So using this website, you can generate a lot of different types of visualization. Only it depends on your creativity, how creative you are, what kind of diagrams you want to generate. For example, stacked bar chart. You can create like x-axis stacked bar chart. I want sub-subject wise, and the size should be, I want to show the size based on the total cost. Okay, and now I can see that the different this and then using this charts series, short series by ascending, maybe name. So likewise I can create. So you can see that the most of the number of the robotics subject field has the maximum number of requests that have been purchased by the library. Similarly, other kind of this can be made. For example, a pie chart. If I want to make a pie chart based on, say, campus wise, which campus, not book cost, total cost, and the divide it by campus. So I can see that Lucknow is the highest one, that has a bigger circle, Chennai and Hyderabad, and then I can further divide it by subjects also. Total cost and campus. So that by hit and trial you have to figure it out. And then there are some hierarchical charts also, like dendrograms we can make. Hierarchy means, like for example, the subject, and then I want sub-subject, and the size should be the total cost, and the color should be based on the subject. So likewise I can generate like this one, and labels also I can generate based on the sub-subject. So you see, robotics, in technology, robotics maximum orders are there. In social science, psychology maximum orders are there. In management, business maximum orders are there. And further I can make it like the customizations can be made. So let me take another example of so for the in terms of the total cost, the high priority, you see, order of priority, high priority are the more, that is means high priority books are usually costly in nature, and the low quality books are cheaper in nature. No low in order preference. So this is one insight that we can generate out of this, and then further we can divide this on the basis of a this one also sub subject wise also. For example, in robotics the high is different, whether it is different or not. For example, in software the critical, this one is more. Similarly for business the high is more, and sociology this one. So subject wise also we can generate. Similarly subject wise also we can generate. Like technology high priority is there, social science high is the higher, and this one is there. So such kind of insights you can generate out of it. Even you can generate whether discount and the book cost correlations also you can generate. Say for example, chord diagram, say the total cost and the discount percentage. It should be number. Let me change to some other. Even tree maps you can generate. So for example, subject and then sub-subject and the total cost and color from sub-subject and labels from sub-subject. So you see, in a tree map, you can see which of the particular subject has a higher this one. Like for example, in the technology one, robotics has higher percentage followed by software, then mathematics and computer science. Similarly for social sciences, psychology, education, sociology, and in business, the biggest share is from in this one management. Biggest share is business and others are very less. And you can further customize this also, like you want to look at like a dice or slice and dice, that also you can change based on your and colors etc. You can make some, this one you can make customizations and export it. So I leave it to you that you go to this website, and even you can go to the, if you want to, like whether this particular, for example, calendar heat maps, and I say order date, and then I say subject color, then I can see that in a particular, for example, in 2012, in which month, which particular subject were procured, the some documents in the particular subject were procured more. I can also print legends also here and show legends, yes, and the legend will be shown on the this one also here. So blue is management and technology, and other combinations are there. So I can see that on this date, on Wednesday, November 21, 2012, management books were ordered. Similarly, the blue dots shows the management books when it was more there. And you see in 2015, very few books were ordered in these months. So you can find out what are the reasons faculty has not recommended or books were not ordered. Whereas in the same year in 2014, several books were ordered here. So maybe these, because they might have already received the books, they're not ordering this year. So you can further explore, and this visualization, such kind of visualizations you can generate. So this is very big, if I keep on going, it will take a lot of time. You can go to any, select any this one, any graph here, chart type, and then you can click on tutorial. So it will show you, say, for example, this is not working. Say some, I think it will show you a video also here, which you can use it to see, and you can view it and see how to make this particular box plot. And it will show you the different ways to make a box plot also. So this is one website. Similarly, I was mentioning, I wanted to show you data wrapper. Here also, say I say start creating, and I have my data set. I upload the data set, click on upload. I can upload the Excel and CSV and say I have one data set here. It has a year, non-fiction, fiction, junior, total. This is there. And then I say check and describe. So it has automatically detected that this is year, non-fiction, fiction, junior, and total. The blue ones are in the numbers, and the black, if it is black, then it is called text, and red indicates that there is some error. So this is fine. Then I click on visualize and a lot of charts are available. And say, for example, here I want a multiple pie chart. So I select multiple pie chart. So I can see that year wise, like for example, this year, uh, every year is in a different color. So I can easily see that for non-fiction category, for under which category, say for example, other has these many books ordered like that. So if I want to see it year wise, I can see, click on the transpose the data button, and I can see for each year what was the distribution. So let me go to this one and remove this one, this particular line, and then generate the different visualizations we can create. See, non-fiction, fiction, and then we can proceed further. Here also a lot of refinements. If I want, I can make like color size if I want to change, and the pie size I want to change, or the labels I want to change, or something that can be done. If I want to insert a title like annual issues, it will be displayed here, and I can also change the layout. And then I can proceed and download the particular this one as PNG. It will send a code. If I give my email ID, I can download from there. So this is data wrapper. So we have to even we can connect Google Sheet also and link external data. In raw graphs also we can connect the uh, in raw graphs also. If I go to app.rawgraphs.io, even I can upload my data. Even I can from URL also I can like for example, if I have a file in Dropbox or in some Google Sheets, and then that Google Sheet has a publicly accessible URL, then I can directly paste it here and the data will be loaded in on this website. So next that I want to show you, because time is limited, I will show you word cloud. Wordclouds.com. This is a very good website to generate word clouds, and this is also a free website. So you can generate a lot of word clouds by this one, and here you have options to extract words from text, extract words from PDF document, extract words from Office document, from web page. So these are basically used when you want to create a, say for example, you want to create a word cloud kind of thing. So say I will just what I will do, I'll copy something from my I have copied text from a paper methodology section, and I have pasted it here, and I am asking it to generate a word cloud. It's very simple. Just paste it. If you have a word list, you can upload that word list also. So it has generated. Now I can select the shape also. Like I do not want this shape. I can select a particular shape also. Like I want this kind of. So it will generate. I can set auto print. I can set a lot of fonts are there. You can set the fonts also from here. And then colors, you can set a lot of colors. Apply. It will change the color. Shapes are different shapes are available. Even you can insert an image also, and then it will generate a shape of that also. And then finally you have this word cloud, and you can download it. control download word cloud, control S, and print word cloud and edit word list that you can do. So I think uh, I think I have completed almost tried to cover most of the tools and also different visualizations that are possible, and in these tools in this specific limited time. So thank you, and if there are any questions you can ask.
Sir, in question answers, there is a question asked by someone. It was which
Mhm.
tool to use for Google Analytics raw data visualization?
Google has already a very good data visualization, this one, and in analytics they provide. And if you have data, you can use any of these tools which I have mentioned. You can either use data wrapper or raw graphs dot. This one also you can use easily.
If anyone have any question, then he or she simply raise their hand. Then I can unmute him or her that he can directly interact with Dr. Vinit. I think Dr. Rijesh, I unmute you. If you have any question, please ask. Dr. Rijesh, Dr. Rijesh, uh, Pankaj, are you want to ask something? I also make you the chance. Pankaj, Bipin, Bipin, you can also ask something. Mr. Bipin, are you want to ask something? Please unmute.
Hello.
Bipin, yes, yes, yes,
Am I audible, sir?
yes, yes, yes.
Hello, sir. I just want to ask this, means in case of daily routine services that are provided by library, so we get so much kind of unstructured data, means that is not in an means not formalized or not according to standards that is used to. So, do we need to standardize our data or something so we can generate that data easily, or in case of research publication, so the data
Mhm.
is in many formats and that is very unstructured in case of research publications of the library of the institutes.
Mhm.
So
Mhm.
how we can generate that visualization data that if we want to predict something in front of library committee, like this is
Okay.
the department or this is the means field we are working on, or we are best, our institute is best in this field. So
Yes. See, your question is very valid, and thank you for that. Basically, the thing is that if you want to generate visualization, the primary thing that is required is data, right? So the data is very much required. So now your question is data is not available, or it is not available in a standard format. So you have to change your policies. You have to change your processes in the library so that you start collecting the data. And the problem with the library staff is that they think that they have their value because they are providing the services, but they are not collecting the data. And if you start doing and collecting data and start presenting the worth by in the terms of data visualization or by performing some studies, I think that authorities will be able to know that what you are doing. Say, for example, the people entering in the library, they are filling in an offline physical register. In place of that, you put some counter or put some QR code scanner that they have to scan while entering, something like that. Some counter you have to make. And if it is there, automatically the data will be with you. Now that data you can use and process it, and then find out in which particular duration more people are coming in the library, and or you have to manually sit and feed the data from the physical register of the library. So it is on the strategic, it is a strategic decision from the, or it's a policy decision from the libraries, whether they want to go with the old practices of not collecting the data, or if they want to have a format where they automatically capture the data or in the physical form, and then again putting somebody to fill that data in. So that you have to do.
Yes, sir. So first of all, I would like to thank Vinit sir for such an informative and insightful presentation, and I would also like to thank all the participants for active involvement in the Q&A session. I would like to also point out that if you have further queries, feel free to contact the LNMIIT Central Library through email. And as all good things come to an end in life, so is this webinar. It is now time for vote of thanks. I request our assistant librarian, Mr. Shubham Giri, to propose vote of thanks. Over to you,
Uh,
sir.
yes, thank you.
Before Shubham comes on this
Yes,
thing,
yes, sir.
I
Yes, sir.
just want to ask Dr. Vinit Kumar whether he will be able to share his PPT, because there could be some queries by the participants later after this,
Yes, yes, yes,
whether it is possible for you to share the
Sir,
PPT.
you are not
yes,
visible
sure.
actually. Sir, you are not visible.
I will share, no problem from my end. I'll share it after the webinar.
Yeah, surely. That is fine. Yes, thank you. Right.
Uh, sir, can I continue?
Go ahead. Go ahead.
Yes. Uh, Good afternoon, everyone. Thanks, Parini, for conducting the webinar beautifully. I, Shubham Giri, Assistant Librarian of LNMIIT and co-coordinator of this enlightening webinar, stand before you with a heart full of gratitude as we come to the close of this enlightening and enriching national level webinar on unlocking library data, transforming raw data into insights through visualization. Today, we had the privilege of gaining insights from an esteemed personality in this field, Dr. Vinit Kumar, Assistant Professor of Department of Library and Information Science, Babasaheb Bhimrao Ambedkar University. A profound debt of gratitude is owed to our esteemed speaker, Dr. Vinit, whose expertise and knowledge have undoubtedly enriched our understanding of visualizing library data. His presentation was informative and inspiring, and we are truly grateful for his contribution to our intellectual growth. First and foremost, I extend my heartfelt thanks to our director, Professor Rahul Banerjee, and the members of the library committee for graciously accepting our invitation and supporting us in organizing this significant event. Their guidance and encouragement have been instrumental in the success of this webinar. I would also like to express our sincere appreciation to Mr. Giridhar Kunkur, our librarian and coordinator, for delivering a warm and welcoming address that set the tone for this insightful gathering. Special thanks are due to Dr. Subrat Kumar Das, Chairman of the LAC, for his enlightening opening remarks, providing valuable perspectives on the subject matter. Our sincere appreciation goes out to the entire LNMIIT Central Library team for their continuous support and encouragement. Their dedication and hard work have been the backbone of this event, and we owe them a depth of gratitude for their tireless efforts. In conclusion, I extend our thanks once again to each and every one of you for your gracious presence and contribution to making this national level webinar a great success. We look forward to our continued support and cooperation in the future. Thank you. Thank you all.
Uh, Before we go to Perini to conclude this, I would like to express my personal gratitude to Dr. Vinit Kumar for delivering such a wonderful webinar today. I think you crossed our expectation much higher, actually. Okay. and we could see absolutely meaningful, you know, insights that you gave to our librarian faculty, and I'm sure everyone should be able to use or make good use of what they learned from today's webinar. And because particularly you covered starting from qualitative and quantitative data, and also how to identify the types of data, levels of measurement, types of information visualization, and also the qualities of good data visualization. And also you took us through some examples of important and very useful tools, and maybe we will explore at least some of them and engage them in our data visualization process, because that is the outcome of this particular
Yes.
webinar. Otherwise, it
Yes.
just should not be just we are hearing the webinar and we are just not using the knowledge that we have gained. So it should be a practical approach. So not only we at LNMIIT Central Library would like to engage some of these tools, and in case there are any hiccups or any problems that we encounter, we shall be definitely getting back to you. And Last but not the least, I would like to express my sincere gratitude to all our wonderful audience who participated from all over India, I should say. And it consisted of the faculty members, research scholars, students, librarians who are heading the institutions or universities, to library professionals and things like that. So it was really a very, very delightful experience for all of us. Thank you so very much for taking out your time. And I sincerely, sincerely appreciate for being with us today and conducting this wonderful webinar. And we look forward to interacting with you more in future. Okay, so this is just the beginning, I should say. Thank you so very much once again.
Thank you. Thank you very much for nice words, Mr. Kunkur. It was a nice and pleasant a feeling for me also to share my the knowledge with the participants of this webinar. And thank you to you for actually calling me for this occasion. Thank you.
Yes. Over
Thank you
to
so much,
Perini.
sir. So I think on
Yes.
that note,